A conjugate is manipulating an algorithm to make it do something different. For example, we can swap this block with this algorithm. But let's say we wanted to swap this block and this block. Well, what we would do is do some setup moves, and as you can see, they're in the exact same spot as when I swapped these two adjacent blocks. So what we can do is just do the algorithm to swap this block and this block. And then we can undo the setup moves, and that swaps two opposite blocks. Here's another example. We can do this algorithm to swap these two corners and these two edges. But if we wanted to swap these two corners and these two edges instead, then we could do a few setup moves, just like this. And if you watched it carefully, the pieces are here, 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 and here, just like when we did this case. So to solve this, we can do a few setup moves, do the algorithm to solve this, and then undo the setup moves. So those two examples you might already know, being the F-perm and the N-perm. But this idea of a conjugate is used a lot in generating a lot of different algorithms. However, let's talk about the algorithm in the middle. Normally, the algorithm in the middle would do some sort of corner swap, corner cycle, edge cycle, you get the point. But let's look at this algorithm. That doesn't look like an algorithm, I hear you say. Well, if you think about it, it does a 4 cycle of corners. We have this corner needing to go to here, and this needs to go here, like moving like that, and a 4 cycle of edges. So this has to go here, which goes here, and it goes like this. So I'm gonna do these 4 moves and watch the last layer pieces closely. It's gonna be F, R, U prime, R prime. Now, as you can see, all the yellow pieces are still on top. So that means I can do any U move, and then if I undo those 4 moves at the beginning, I will only be affecting last layer pieces. So let's say we do a U, and then we do R, U, R prime, F prime. So if we just reverse that, we could get a 1 look last layer or even an OLO algorithm. Let's try another one. We're going to do R prime, F2, R2, U2, R prime. Now, all the yellow pieces, where are they? They aren't all on the top, they're actually on the front face. As you can see, they're all here. So what we could do is we can do any F move. Let's just do an F, and then we'll undo the moves at the beginning. So that'll be R, U2, R2, F2, R. So if we just do the reverse of that, we've just solved a 1 look last layer or even another OLO algorithm. If you found that a little confusing, I'll explain it on this sandwich cube. So what this cube is, every single layer has its own color. So the blue layer has its own color, and the yellow and the red. And the blue layer pieces are the last layer pieces, so we'll be focusing on them. So let's try something else. We can do R, U prime, R2, D prime, wide R. As you can see, all the yellow pieces are still here. And then we'll just do a U move, because why not, and then we'll undo it. So it goes like this. And if we undo it, we can solve an OLO case. So I'll explain it on here. So R, U prime, R2, D prime, wide R. Now as you can see, the blue center isn't here, but that doesn't matter because when we undo the moves, the center will just move back and all these centers will move back. So as you can see, pretty much all of the last layer is blue, or last layer pieces. So we can just turn the top however much we want, and once we undo the rest, only the last layer should be affected. So basically what I'm saying is, if you can find a set of moves that keeps the last layer pieces on top, or they can be on any face, and then you turn that face, so here the yellow pieces are on the top, so I'll turn the top, then you undo the setup moves, you'll have an algorithm that only affects last layer pieces. And also, once you get all the pieces into a particular layer, you can turn that layer either once, twice, or anti-clockwise, and basically that will give you 3 algorithms to try out, which is quite cool. Alright, that's it, and I hope you've learned something new. See if you can come up with your own algorithms based on this one move conjugation. Alright, thanks for watching and I'll see you next time.